Now it's my pleasure to introduce our second speaker this afternoon, Ricardo Hausmann. He's a professor of the practice of economic development at Harvard University and the director of the Harvard Center for International Development. It's been great having Ricardo around SFI the past year. The kind of economic research he does and looking at a variety of complex systems has resonated with a number of people, and we're delighted to have him with us. So please join me in welcoming Ricardo Hausmann.
Let me start by saying how incredibly honored and excited I am of being a Cowan professor. When they told me who the other Cowan professors were, I got really excited because I said, who's this guy, Robert Boyd? Let me see what he's written. And I read his book, Not by Genes Alone, and you'll see how it has influenced my thinking. I also read this book by the autobiography by George Cowan, and it's amazing how a kid from Worcester, Massachusetts, did all these things and was part of so much of the history of the 20th century, the Manhattan Project, the A-bomb, and now the Santa Fe Institute. Always when you want to start to get a new perspective on something, it's usually good to start by thinking that that something may be made by something, may be composed of something very different from the thing you are used to describe it with. So, for example, if you ask yourself, what is the world made out of? This is a good explanation, right? It lasted thousands of years, right? Earth, water, wind, and fire. I couldn't take a picture of the quintessence, but if you ask Murray Gell-Mann back there, he will tell you, no, it's made out of these few things, and actually it's a very simple thing. It's made out of these, this is the standard model, and he came up with that because everybody was concerned about something that they called the particle zoo, that there were too many particles, and God would not have been that messy. He would have found a simpler order in this. But the point is that these things aggregate into stuff that is orderly, or but with some interesting insights that chemical properties recur with some cycles and so on. And then these things sort of like get mixed together into bigger molecules, and then into even bigger molecules, and then into even bigger molecules, and then into things like this. They ended up aggregating into something like that, right? And I'm going to talk about more something like this, okay? But all of them coexist at the Santa Fe Institute, which is amazing to know. If you think scaling laws that Jeff West talks about within an institution. Okay. So I'm going to talk about the following things. I'm going to talk about the great acceleration in world growth. I'm going to talk about the great divergence. And then, since everybody else talks about resilience, I'll put the word resilience there and tell you a little bit about resilience. And then I'm going to talk about the new convergence. So let me tell you what this is about. Forever, incomes per capita were amazingly stable in the world. We know that. And then over the last 200 years, they exploded. And in the US, this represents a factor of 25. Incomes per capita, now vis-a-vis 1820, have gone up by a factor of 25. Okay? So that's the great acceleration. It didn't happen before. It happened only in the last 200 years. Now, this didn't happen everywhere. It happened in some parts of the world and not in other parts of the world. And that's weird because Robert Boyd told us that we're really good at imitating, right? So something is preventing imitation. So if you take income per capita in 1820, the richest country in the world was approximately 4 times richer than the poorest country in the world. Now the US is about 120 times richer than the Congo. So there's been this huge expansion in the distribution of incomes of these humans that have populated the whole planet. So this means that if you take how many times is the US richer than, say, China or India, well, it went from being 2 to 3 times richer in 1820 to being something like 20 times richer by 1970. Okay? So that's what we call the Great Divergence. Okay? Now, if you take the data from 1970 onwards, you get this. You get that now China and India are catching up. The US is only like 3 times richer than China and like 10 times richer than India, no longer 20 times, okay? But it's not happening everywhere. So some parts of the world are converging, and other parts of the world, like Nigeria, is not converging, okay? So I want a theory that explains all of this, okay? Now, this is what I added to make it more, okay? It's not only that countries are poorer, they're also less resilient. So I'll ask the following question. How many industrial countries, the 24 rich countries, have their highest GDP per capita before the year 2000? How many of the rich countries had their peak GDP per capita before the year 2000? 0. Very good. So none of the rich countries had their peak. Okay, now, and why? Because if you look at GDP per capita, it kind of looks like that, right? And even the US, I added up the last data because it's sort of like getting to the level of 2007 slowly. And the reason why the peak is not too far behind is that it has this upward trend and then some wiggles, and the last peak is never too far away from the current one. So the wiggles causes something hit it, and the thing has resilience in the sense it bounces back, or maybe John would have said bounces forward or something. Okay, so same question. Out of 112 developing countries with data since 1980, how many had their peak GDP per capita before the year 2000?
95.
Oh. It's actually 58%. Okay? 58%, and some of them had their peak, a generation ago. Okay? And the reason, and this is for Africa, it's about 74%, and for Latin America, and the reason is if you look at the time series, it looks like this. Zambia got hit in 1975 and never recovered. This is for Latin America, it's about 15 out of 27. And the reason is, they got hit, sometimes something happened, El Salvador or Guatemala, they come down and it takes them a long time to recover. So I looked at these collapses and sort of like measure, okay, when did GDP fall? How long did it last until it went back to its original level? What was the peak to trough decline? And what's sort of like the interval under the curve, okay? And if you look at for industrialized countries and the non-industrialized countries, this is duration, they're much longer. This is by region. They're much longer. This is the industrialized, this here is the industrialized countries. So compared to that, it's much longer. Not just the median is about always 3 times bigger in the developing world, but, the distribution is just huge, right? You go beyond the median. That's peak to trough, and that's, the cumulative GDP loss. This is the industrialized countries. And this is, 15 years of GDP loss is the maximum. But so these places are much less resilient. So not only are they poor, they're much less resilient. Well, let me just skip that. So why did the US become 25 times richer? Okay? If you ask, an economist used to believe that it was because, you make stuff out of these things here, earth, water, wind, and fire, right? And, you just get more of this stuff, and you get more output. And what, endogenous growth and what economists have learned is that this is not the answer. That's not how the U.S. became 25 times richer. The U.S. became 25 times richer because, as Robert Boyd was saying, they developed a bunch of new stuff, okay? So it's not that we're producing 25 times more than we were 200 years ago of the same stuff. We're producing completely different things with completely different methods. So we learned a lot of stuff. So we know much more. We have much more productive knowledge, many more tools, many more ideas, many more processes than we did before. That's why we're 25 times richer, okay? Now, you'll see the influence of people in Santa Fe affecting other people. So I'm going to ask a question, since this has been, who has more productive knowledge? an Inuit. Okay, so here's the Inuits. Let's talk Inuits all afternoon, I guess. So this is Inuits engaged in food production. These are the Inuits engaged in housing construction. And these are the Inuits engaged in transportation. Okay? So I want to know who knows more, the Inuits or modern man. Okay? So now, the interesting thing about modern man is that this guy uses a shirt, doesn't have a clue how to make a shirt. He uses glasses, doesn't know how to make glasses. He uses a computer, doesn't know how to make a computer. He uses software, doesn't know how to make software. This guy, if you put him back here, he dies, starves to death, or freezes, right? I mean, there is no sense in which you can say that this guy knows more than the Inuit. So how can we say that we became 25 times richer because we know more? Since modern man doesn't know more at the individual level. Okay, so it must be that we are richer because we know more at the social level. So here I'm going to steal an idea from Jeff West. Jeff West, in his scaling stuff on biology, says, well, you know, a rat and a blue whale at the micro level are all powered by the same battery. And the same battery is the mitochondria. So the mitochondria has to power a rat and a blue whale. Okay? So I'm going to assume that there's a limit to how much an individual can know how to do. Not facts about the world, know how to do. You know. So, you know, you can learn to make arrows or igloos or software or shirts, right? But you cannot learn to make everything. So there's going to be a limit on how much you're going to learn. And I'm going to call that limit a person byte. So, okay? So you're limited to 1 person byte. You decide what you stick into your hard drive. There's so much you can stick in, okay? So what happens is that in the Inuit society, pretty much everybody has the same person byte. Everybody knows how to hunt, everybody knows how to fish, everybody knows how to make their igloo. Everybody has a copy of the same person byte. A complex society has many person bytes, has a hecto person byte, a kilo person byte, a mega person byte, okay? So that's the sense in which you can have more knowledge at the social level, even though the individual is limited by his single person byte. So the idea here, right, is that you scale knowledge through the division of knowledge, which has to do with Adam Smith's idea of the division of labor, right? But it's knowledge that has to be decided. So, for example, when Harvard was founded in 1636, there was a certain stock of knowledge. They didn't know the physics, the biology, the chemistry, the ecology, the political science, etc. So that knowledge fit here in Mass Hall. Then, you know, more knowledge was created, so they needed bigger buildings, and then bigger buildings, right, more to store that knowledge, and bigger buildings, okay? So now, when they started, a college degree lasted 4 years. Now, obviously, with 50 times more knowledge, a college degree needs to last 200 years, right? No, that's not actually what happened. What happened is that now we have 50 majors, right? So it's the idea that in order to store this knowledge, you have to divide this knowledge in society. You have to specialize. But once you have done this, how are you going to use this knowledge? So products are made with knowledge. I'm going to make an experiment. I do this every time. See, can anybody tell me here what are lipid salts good for? Lipid salts? So you see lipid salts, right? So, who said? Eso, good. So it's good to make soap. Now, see, you're learned people. Somebody said you have the highest IQ that he's ever, Robert said, I think. So we use soap every day. It's part of the things that makes our welfare high. But we don't know what soap is made out of. We wouldn't know how to synthesize it. We wouldn't know how to preserve it, etc. So our well-being depends on our access to a lot of knowledge that we don't have individually, right? But in order But products are going to differ in the amount of knowledge that they require. So if a product requires more than one person byte, it cannot be done by a person. Somebody mentioned iPencil, which is a really fantastic book. So to create a product that has more than one person byte, you need to bring people together. And this is done by putting people together in firms. And this may not be enough by buying intermediate inputs from other firms, so in the value chain or in the market. Right? So you can imagine that each one of these products is going to have some kind of amount of person bytes behind them. You can imagine that these products might have been done in a family farm, except maybe for the agrochemicals or the pesticides or something, right, that these guys would not have known how to make. But this could not have been made in a family shop, right? And this stuff cannot be even made in a country. It has to be made in a network of firms across the world to be able to make it, right? So products are going to differ in the amount of person bytes that they have. Now, that doesn't mean that big companies have many person bytes. This is a Chinese company that makes chicken parts, okay? And you can see people sort of like the same person byte until the horizon, everybody, cutting up chicken. And that's very different from these kinds of processes, right, where everyone is doing something different, and that aggregates into something more complicated. Okay. So what I need to do with these insights is I need to measure how many person bytes does a society have. Then I need to show that this actually explains why countries are rich and why countries are poor. How many person bytes the society holds determines on who is rich and who's poor. I'm going to develop a theory of how person bytes get accumulated, so how countries grow, essentially. And then I'm going to explain what caused the Great Divergence and what's causing the new convergence. That's what I want to show. Okay, so in order to measure the amount of knowledge in an economy, you have to look at the world. And here's a picture of the world that Robert has already shown us. The only problem is that the information I want is not here. It's actually here. It's much easier to read from here than from here. Now, what is this? This is a matrix in which each row is a country, and each column is a product. And each pixel is how much of each product each country made. Now, the only reason why it's hard to read, maybe, is that these countries are ordered alphabetically, and products are ordered according to some bureaucratic code. But if you allow me to reorder the countries and reorder the products, you get this. And this shows an enormous structure in the world. This says that some countries make everything, and other countries make very few things. Ecologists would call this a nested structure. Okay? That some products are made by everybody, and other products are made in few places. But what gives it its triangular structure is the fact that the countries that make few things make things that everybody can make. And the countries that make many things make products that few other countries can make, but can also make the products that everybody makes. Okay? So we need a theory to explain this fact. Why would this be a feature of the world we live in? Okay? Why is it that some countries make few things and other countries make more things, and in a nested way? They include the previous ones. And this is not just at the global level, looking at products that get traded internationally. This is true at the national level. These are municipalities in Chile in which industries are present in those municipalities. You get the same structure. So the theory I'm going to have is going to be based on two simple ideas. The first thing is that products are made with person bytes. Okay? Different person bytes, think of them as different pieces of a Lego puzzle. And then countries are repositories of different person bytes. So the countries are going to be making the products for which they have the requisite person bytes. So what I have just shown you is this. Is who makes what. And I'm positing that who makes what is a function of who has which knowledge, which person bytes. Okay? So the intuition is that countries that have more person bytes have what it takes to make more products. So they'll be more diversified. They make more stuff. Products that require more person bytes, are more complex in that sense, will be accessible only to the countries that have all that it takes, so they'll be less ubiquitous. Fewer countries will be able to make them. Countries that have more person bytes will be able to make products that require more person bytes. So they'll be able to make longer and more complex products, products that are less ubiquitous. Therefore, we should observe that the countries that have more person bytes are simultaneously more diverse and are able to make products that are less ubiquitous, harder to make. So when we look at the world, that's exactly what we find. We find that rich countries make many things and things that few other countries are able to make. Poor countries make few things and things that everybody is able to make. And this is true not only at the national level, this is true at the municipal level in Chile, this is true at the city level in Turkey, and this is true at the metropolitan level in the US. Okay? So this is a feature of the world. So, so another way of saying the same thing, this is another metaphor, is to think that things are made, the economy is a game of Scrabble. Okay? So if you have few letters, you can make few words. If you have only the letter A, you can only make one word, A. Right? If I give you 3 letters, you can make these 4 words, actually. The letter A and at, cat, act, right? If I give you 4 letters, you can make 7 words. Actually, 8 words, because I forgot the letter A. Okay? If I give you these 10 letters, you can make 595 words. And if I give you the alphabet, you can make all the dictionary, right? So actually, I need to figure out what's the relationship between how many letters you have and how many words you can write. Okay? And that relationship is going to depend on how big is the alphabet and how complex are products. If products are made each one with 1 letter, right? If you have 5 different letters, you make 5 different products. If you have 10 different letters, so it would be a very linear relationship. But as products become more complex, unless you have all the letters that it takes, you cannot make the product. So this says the relationship on what proportion, given that you have what proportion of the alphabet, what proportion of the dictionary you can write. Okay? And this is a very convex relationship. Okay? And it says that as the alphabet becomes longer, and as words become longer, the relationship becomes more convex. Okay? That's the essential idea. And when we estimate this model with the data of the world that I have just shown you, we get these estimates, depending on which data sets we use. So the world we live in is very convex. And this is, in essence, our theory of the Great Divergence. What caused the Great Divergence is that you need to have many letters to be able to make any words. If you have 40% of, if you have 40% of the letters, you make one product, you don't make much. And not only that, if you have very few letters, if I give you one more letter here, you don't do anything with it. But if you are here, and I give you one more letter, you can recombine that letter with all the letters you have to make many more words, right? So the guys that are here have few letters and have few incentives to accumulate more letters because they don't have opportunities to recombine those letters. While here, the incentives to recombine are very large. So this is what caused probably the great acceleration, and this is what caused the great divergence. And in fact, probably over the last 200 years, the alphabet has gotten longer, words have gotten longer, so this relationship for a long time became more convex. So the countries that did not have what it takes at the beginning could not catch up. So this is my theory of the great divergence. Now, how would you go about measuring how many letters does a country have? And somebody said not to use math, so I'm going not to use math. So I'm going to essentially say we're going to use the same algorithm that is used to decide who wins college football. That is, First of all, you count how many games each team won. But some teams might have become lucky and had to play only weak teams, right? But how do we know that those teams are weak? Well, by how many games they won, right? But then you ask yourself, well, but maybe they were lucky and they beat weak teams. How would you know that those teams were weak? Well, by how many games were won by the teams they won. Okay? This is essentially the same algorithm as PageRank. So essentially, with the same data I showed you in that matrix, we can calculate, we can infer from the products you make, from how many other countries can make those products, from how many other products these countries are able to make, and so on. We can infer how many letters you have. So this is our measure of how many person bytes your society has. And you see that for the blue countries are countries where exports of natural resources are small. And for those countries, the relationship is super tight. Is 75% is the R square. And the red countries are countries in which natural resources are important. And what you find is that those countries are richer than would be predicted by the person bytes that they have. The red ones are above the blue ones. If I control for how rich you are in natural resources, you get this relationship. A very tight relationship between how much you know how to do and how rich you are. So this is, how diverse is your technology set and how rich you are. Now, you can say, well, the R square is 0.73. Can I do better? Maybe, the theory is imperfect. Maybe the theory should be more perfect. If I were Argentinian, I would say, no, that's not the problem. The theory is not the problem. The world is imperfect. The theory is okay. In the sense that these are not errors. These terms contain information. And the information they contain is that, for example, it says India, given all the person bytes that they have, is a country that should be richer. It should be up here. And it's down here. So you'd say, well, maybe India does not belong here. It belongs there. Maybe India should grow fast. They have already what it takes to be richer. So this would say countries would tend to converge to where they belong. So this quote-unquote error should predict future growth. For example, this country here is Greece. This would say, gee, how is Greece so rich given how little they know? So maybe Greece should not be so rich, right? Maybe Greece is in the process of going where it belongs. Right? So actually, these error terms predict future growth. Countries tend to converge to a level of income that they can support with their person bytes, with their knowledge. Okay? So the next question, how are these person bytes accumulated? Well, to accumulate these person bytes, you need to solve a complicated chicken and egg problem. The complicated chicken and egg problem is that you cannot make watches unless you have watchmakers. You cannot make products if you don't have the letters. But nobody wants to invest in letters that are used by industries that don't exist. Right? So you don't want to become a watchmaker if nobody's making watches. And even if you wanted to become a watchmaker, you don't have other watchmakers to learn from. So the question is, how are new technologies ever introduced, right? If the people who have to learn have no industry that uses that technology and so on. And the answer, how does the world deal with it? The answer is that the world deals with it by minimizing on this chicken and egg problem. And they minimize on this chicken and egg problem by moving from the products they're in to products that are nearby, to products that imply some recombination of what they already have and maybe add a letter or two, so that the chicken and egg problem is less overwhelming. Okay? So that if you can start exporting something, you need ports, you need something to get to the port, but you don't get to the port in a refrigerated way, so you cannot send fresh produce yet, right? But maybe next you put a containerized cold chain, and then maybe you can do something else, right? So this is the sense of the letters. So we developed a measure of how related are products in terms of the similarity of their letters, and this is what we published in Science in 2007 with my colleagues Cesar Hidalgo and Laszlo Barabasi and Bailey Klinger, who was my PhD student. And here each circle is a product, and it's connected to other products that are similar. So the intuition is that it's easier to move from a product you're in to a product that is nearby, captured by this network. Okay? So the accumulation of knowledge is going to be easier by moving to related products. And this is our current version of the product space. These are electronics, these are chemicals, this is machinery, this is construction materials and stuff, this is garments, and there's a bunch of stuff that is very peripheral. They are, like oil is out here. It's a product that doesn't have many related products. You really need to be good at making holes on the ground. So if you need holes on the ground, I'm from Venezuela. We know how to make holes on the ground, but besides for oil, it's not used for much else, right? So products are going to differ in how many neighbors they have, and they're going to differ in how complex they are, in terms of how many letters they have. So machinery, for example, uses many letters, but because it uses many letters, there are many recombinations of letters that are nearby that you can move to, okay? So let me just illustrate this with a couple of examples. I'm going to compare Ghana and Thailand. So Ghana is a country that, this is years of schooling in Ghana and Thailand. And in Ghana, years of schooling went up faster, and it's in English. You know English, the lingua franca, and so on. So now this is GDP per capita in Ghana, which is the success story of West Africa since 1985. So it's gone up nicely. But it came from a not so great previous past, but so it's growing now. And if you look at what is it that Ghana knows how to make, they make cocoa, aluminum, wood, essentially in 1975. If I happen to look a generation later, say in the year 2000, they make cocoa, aluminum, wood, and now fish and diamonds. So that's the expansion of what it is that they know how to make and export. So this is what their exports look like. And if we look at where was Ghana in 1975 in this product space, it's where these squares, black squares are. Okay, that's what they know how to do. And by 2008, they were already here. They had, 75, 2008. You see how they expanded from where they were. So let's look at Thailand. Thailand in 1975 was making sugar, vegetables, sugar, corn, rice, tin, and fish, and wood. Okay, a little bit. Let's look a generation later. So here, in between tropical agricultural cereals, raw materials, and animal products, they have 80% of their exports. Okay? A generation later, it's 50% machinery. Electric microcircuits, cars, digital central storage pieces, a bunch of apparel that was not there before, and they still have their sugar, their rice, etc. So this is the way it looks. So you see a huge expansion in person bytes, even though they accumulated fewer years of schooling. They accumulated fewer years of schooling, right? And if you look at what happened here in the product space, this is where they were in 1979, 75. There's nothing here, there's nothing here, there's nothing here. There's very little here, right? And boom, they're all over here, they're all over here, they're all over here. They're not really here yet in chemical products and so on. So when I compare how much each country grew, this is how it looks like. So this divergence is really a divergence in what it is that you know how to do, not what's the divergence, how many years did your kids spend in school, okay? Well, let me skip through this. This is Korea between 1965 and 1970. It's mostly textiles and stuff, and this is what happened afterwards. Okay, so let me skip this. Okay, so how do we explain growth? Well, we explain growth by saying, look, first you're going to converge to the amount of knowledge you have, and then you're going to accumulate knowledge. And you're going to accumulate knowledge depending on where you are in this product space. Because if you are in a part of the product space that has many neighbors, it's going to be very easy for you to move from where you are to the next thing. But if you're in this very peripheral part of the product space, there's nothing nearby. We've used this metaphor that this product space is like a forest, and your country is a bunch of monkeys that populate certain trees in that forest. So the question is, can these monkeys diffuse in this forest? And it depends on how many monkeys you started with and how peripheral were they in the process. Right? So we need to measure how near are the products you're not making from the products you are making in this space. And we have a way of measuring that, and this is what we get. So this is the number of person bytes you have. This is how much knowledge you have, and this is how well positioned you are in the product space. Okay? How easy it would be for you to get more letters. And with these two variables that you see here, we explain growth. Okay? We explain growth remarkably well. So these are the countries with few letters, and with few letters you make few words, and it's hard to make more combinations if I give you more. There's an intermediate group of countries that are now in a sweet spot, that if I give them more letters, they can make a lot of more stuff. And these are countries that are already making everything. It's very hard for them just to make more stuff by imitating others, because they've already imitated. So these rich countries, the only way they can grow is by inventing new things. And everybody's been talking about innovation and stuff. But what I'm really focused on is not so much the innovation process as to the question, why did humans in these poor countries not mimic, copy what the world had already invented? Why is it that they were not making cars when cars were already there? Why is it that they were not making photographic material when photographic material had already been invented? Why had this technology not diffused? So this is our preferred specification. We control for how rich you are in natural resources, your initial level of income, and these are our two variables. And we do a spectacular job, my opinion, of explaining growth. But we do a particular spectacular job compared, if you put our theory in a horse race with other explanations, for example, compared with formal education. I've already intuited that comparing Thailand to Ghana. Compared to governance indicators, it's all about rule of law, the quality of your institutions, corruption, and so on. Or competitiveness as measured by the World Economic Forum, we beat the hell out of them too. So we say we have a plausible theory of what is behind this growth process. It's this accumulation of knowledge that has to be distributed in society and then reaggregated through linking people in firms and linking firms in the market. Okay, that's the mechanics of it. Okay, so now I have to explain why did we see divergence then and why we're seeing convergence now. So if I make this calculation, this is how many person bytes you have, and this is how well positioned you are in the product space. In 1978, the relationship was convex. So now I'm going to pass you the history of the last 30 years. Look at what has happened to this shape. Okay? It used to be that the countries that had a lot of person bytes could accumulate many person bytes very easily. But as time has gone on, the sweet spot of how easy it is to accumulate more person bytes has moved more to the center of the distribution. Okay? So we made a decomposition, asking ourselves, why did this happen? Is it that countries have moved into other parts of the product space that have populated more? Is it? So this is what we find now. Okay, so this is today's production with today's shape of this product space. And this is today's production with what the products, if had this network remained at 1978 levels. So if we had not changed the technology, so this product space is a measure of technological relationships. So my question is, what happened is, where are these monkeys? Or did the monkeys move or did the trees move? So this is today's monkeys with today's forest. And this is today's monkeys with yesterday's forest. And the idea is that if we had yesterday's forest, the relationship would have remained in favor of the rich countries. But since the technology changed, now it's made it easier for intermediate countries to accumulate more letters. What do we think caused this? What we think caused this is globalization. That products, for technological reasons, products may be becoming more complex. Like your camera has more features. But value chains have become more disseminated. So right now, every place needs to have fewer letters in place, in situ, to form part of this production chain. So it's like each location has an easier time now to get into the business. They don't need to have as many letters as before because you don't need to design the shirt, you don't need to market the shirt, you don't need to brand the shirt, you just need to cut and sew. Somebody else is doing the rest of the stuff. So you can get into the business by having fewer letters. So it's like we are now moving from a world that trades words to a world that trades syllables. And syllables are shorter than words. And that makes more of the product space accessible to more places. So products are becoming more complex, but the production process is becoming simpler in each location. And that is what the reason, we would argue, now the fast-growing countries are middle-income countries. Globalization has made it easier for them to advance. So, I mean, the example of Lenovo is a cool one because IBM would ask Lenovo to assemble their computers, and then Lenovo said, well, what about if we procure the stuff ourselves? And what about if we do some design ourselves? And what about if we do the distribution ourselves? And then eventually Lenovo said, IBM, what are you doing here? Get out of here. Right? We don't need you anymore. So we've accumulated the letters more gradually. Had they had to have all those letters to begin with, they would never have gotten there. Key findings on our work on resilience is that several factors are associated with the onset of crisis. You typically get hit by something. Wars, export collapses, sudden stop in capital flows, political transition, something happens. And these factors are generally not associated with how long is the crisis, how deep is the crisis, what's the loss associated with the crisis. But the best predictor of how deep, how long, how durable is the crisis is your position in the product space. And this has to do with what Michael said in the previous session, that if you were exporting something and I hit you in that export, the question is how easy it is for you to recombine the letters that you have to make something else. And that depends on how centrally located you're in the product space. So if you're Chile exporting farmed salmon, and you're Malaysia exporting microwave ovens, if tomorrow the market for salmon and microwave ovens disappears, right, what does the morning after look like? Well, if you're making salmon, you cannot move to trout. That's a completely different animal, different biology, different, right? But if you were making microwave ovens with the same production line, the same workers, the same everything, you could make 100 other things. So that's what we call your position in the product space, how close you are to alternative uses of your capabilities. So summing up, what caused the great acceleration was a phase transition in productive knowledge, an explosion in the possibilities of recombination. That was the Industrial Revolution, if you want. What caused the great divergence is this convex relationship. The guys who started with few things could not get into it, and as technology evolved, the number of letters was expanding, words were getting longer, they were less and less able to have the incentives to accumulate more letters. What caused the great convergence? Globalization. The idea that the value chain became globalized so that each place now needs to have fewer letters to get into the business, so it becomes less convex. But not for all countries. The countries I showed you at the left of the distribution are still trapped. They have no incentives to accumulate more letters because there's nothing they can do with more letters given how few letters they have. Can information accelerate the process? Would this process be faster if the world knew that there's a map out there? Okay? So we have created this observatory that allows each country to find out where they are in the product space, what's nearby, or investors asking themselves a question, could this country move into this thing given what they already know how to do? And the idea is that with more information, maybe this process could be somehow accelerated. So that's what I wanted to say. Thank you very much.
Ricardo, according to this theory, it doesn't matter what policy governments make. Do you think that is part of your theory?
Well, I teach at a public policy school, and I spend a lot of time talking to governments. So I think that there's a role for government. It is a very particular role for government. The government is in the business of solving these coordination failures, these coordination problems. But this is a very complex space. And governments don't necessarily have the information of what's missing, what is possible, and what are the things that are missing to make those things possible. So this is a government, it has to be a 2.0 government that is keenly aware that it does not know what it needs to know. So it knows that it doesn't know. And it has to have a structure whereby it interacts enough with civil society to identify what are the gaps that are making some things that could potentially be feasible, make them feasible. So that's what I think the role for policy is. It's a solution of coordination failures. The reason why the U.S. is a powerhouse in aircraft is because the government told Boeing and stuff, I want a military airplane no matter what it costs. You figure out. And once they got to figure out how to make a military aircraft with those same letters, it was fairly easy to move to commercial aircraft, right? So there's a process of accumulation of letters for some reason, and then the redeployment of letters. And the question is, what are the instances in which governments can facilitate those processes? Sometimes they're obvious, like there's no power, there's no water, there are no roads, there's no ports, there's no training facilities for workers, there's no security. So you don't have those letters around, it's very hard to make things, right? Other times they're more subtle. You cannot export avocados from Mexico to the U.S. unless you sign a phytosanitary agreement with the U.S. So they have to sit down. In fact, it's at the state level. Agree on the phytosanitary rules to create the market for avocados in the U.S. So what it is that is missing is going to be a function of where in this product space you are and what is the opportunity you're trying to seize.
That was a wonderful talk. Thank you very much. You skipped over a couple of slides that you had there on trade, and I want to. You might want to go back to that since we seem to have a minute or two. But also, I'm looking at the Latin American, Central American countries that you must know a lot about. Some of the rise in GDP prior to the collapse in those peninsular countries was the growing effectiveness of the business enterprise that drove the banana republic. So there were innovations from outside those countries in transportation and growing fruits and getting them shipped and having them be good when they got there and so on. So could you say a little bit about the things that happen outside your country that may permit this? And then maybe that not disagreeing with your theory at all, maybe that explains why there was no resilience when the political structure basically ended the economic colonialism. There was nothing to bounce back from. But could you riff on that a little bit?
Yeah, well, the puzzle is why technology diffuses so slowly. It's not that technology does not diffuse. So, for example, when the colonial powers, or even, Latin America, discovered an Ethiopian seed, which transformed its economy. You know what that Ethiopian seed is called? Coffee. So, they discovered coffee, and suddenly, you have whole communities that are organized around coffee growing, right? So, or when, bananas or sugar, or it is forms of livelihood that depend on a technology that has the advantage of creating a product that is unexportable. And consequently, if you are able to make a product that is unexportable, you then can have access to lipid salts, right? You can have access to the knowledge that other people have by trading with it, right? But what's going to limit your ability to get lipid salts is what it is that you're going to give in exchange. And then the question is, what is it that you are able to make? So yes, for example, I come from Venezuela. Venezuela, we have this story that, we have always been exploited by these Yankee imperialists and stuff, right? But the truth of the matter is that in Mesopotamia, they used petroleum for medicinal purposes. I don't think that there are any medicinal purposes associated with oil. The reason why oil is valuable is that somebody invented the internal combustion engine, somebody invented metallurgy, somebody invented the car, somebody invented geology, somebody invented how to drill, somebody invented how to find oil, and we were just sitting around on top of the oil. So it's not that the reason why oil is valuable is that it's a complement of a lot of know-how that other people developed. Now, yes, that knowledge had to come in for that oil to be valuable. So we have benefited enormously from the accumulation of knowledge in the world that without it, oil would have been worthless. So, but the problem in Central America is that essentially they developed very few things. They became increasingly urbanized societies, and they were able to export few things out of their integrated cities. One of the very contrasting things between Latin America and East Asia is that in East Asia, exports come out of cities. In Latin America, there are no exports coming out of cities. Exports come from somewhere in the countryside, which means that as city grows, there is no scalable industry that is not limited by the size of the domestic market in urban areas. In urban areas. So I would put it to you that for political reasons or other, they simply did not find the next Ethiopian seed. They did not find the next product that could generate the next form of livelihood that could sustain their incomes.
So do you have any idea whether or not your analysis would change significantly if you took into account that every letter or person byte, I suppose, actually had very different value depending on context specifically? One piece of knowledge isn't necessarily equal to another when it comes to creating economic activity.
Well, absolutely. I mean, one letter is only valuable in the context of what other letters are there in the production of which word. So, the problem that you have when there's, I don't know, my son is a theater director. Okay? In Caracas, he tried to put together a theater company and so on. But there are no theater halls that you can rent. You cannot sell tickets through the internet. There's no sponsors, right? So there's no ecosystem around you. So how valuable is your letter depends on what's the ecosystem around you. And that's why people have been so focused on, this is it's very clear in business schools, they talk about business ecosystems. It's very abstract for economists because we think the world is made out of earth, water, wind, and fire. And consequently, everybody has a little bit of that. Everybody should be able to make everything because everybody has, yes, definitely. Your value depends on the presence of complementary inputs that you have.
But is there any way to actually, that you know of, to look at that and see if it actually changes the results of your analysis? Because as far as I can tell, and correct me if I'm wrong, you're treating all of these person bytes as approximately equal.
No, remember, it's not that the person bytes are equal. They're different. That is, in some sense, I'm saying a person has a limit in how much he can know. But when I say a society has more person bytes, is that there's more heterogeneity in the knowledge set, right? Person bytes have to be different to be valuable. If they're copies of the same, it's like the Chinese chicken factory. So no. When I think of person bytes, I think of the diversity of person bytes. If you want to think in physics, I'm not thinking of the intensity of light, I'm thinking of the spectrum of light, right? So it is the spectrum of light that gives value to your little line, if you want, in the spectrum. If a rich country tends to make long words are more valuable than short words per letter. Okay, so the fact that you're able to cooperate in a complex product like that airplane, that was the Dreamliner, right? That the people participating in that process are going to generate more value than somebody making only a piece of a standalone piece of things.
Can
One more here, and then I think we'll have to stop. But if others, if Ricardo stay, we can certainly
Sure.
Ricardo, can your model predict the emergence of new industries? So looking at the product space map, for instance, if there are holes somewhere, eventually those holes will get occupied, like Google, for instance, between advertising and internet search.
Our model does a remarkable job at predicting which industries are going to appear where and which industries are going to disappear where. If you do, these, we have a upcoming paper that uses this, the area under the curve of the ROC operator to estimate how good we are at predicting. So we get, 82, 85%, true positives to false positive rates in terms of industry appearances and disappearances. But these are products that have already been invented. And this is about predicting where they will diffuse. But predicting of which new industry is going to be invented at the global level, no. I can't. That the people in Silicon Valley will know more about that. But the data, because of the nature of this process, how know-how is accumulated, the data does predict which industries are the right locations in the next step. And actually, we're trying to build these tools so that people can use them more operationally. That we have this project with the government of Brazil, where we are trying to predict in which municipalities. The question is, which municipalities are ripe for which industries? Or if you're an investor, if I want to locate in Brazil, what is a city that has what it takes to host me, right? And that data is embedded in the network of what that city is already able to make, and who else makes the things that city makes, and so on. So that information is embedded there, and it's highly predictive according to this view of the world.
We're grateful for the vision of George Cowan, who allowed us to have people like Ricardo Hausmann, Rob Boyd, Mazrin Banaji join us regularly, and we look forward to more opportunities. So please join me in thanking you.